Okay guys, so for section 4.9, you guys are just supposed to fill this in. This is just following along in your book and showing an example using a parabola and the graph change scale theorem. So basically remember 4.9 is just 4.8 and 4.7 put together. So first you're going to do a scale change and you're going to do a translation all together. So here you can copy this from your book too, the rubber band transformation, composite of scale changes and translations, the graph standardized theorem, so you can write that in there. You should already have that done. And then state the graph standardization that it applies to circular functions. So we have the sine function, the cosine. Remember, this is a translation, vertical, horizontal shift, or remember, horizontal shift is the same as phase shift. And then you have scale changes as well. So this is all together. And so again, your amplitude is absolute value of B still. Okay, so the B can be here or over here. Your period is still 2A times the absolute value of A. Your phase shift is K, or H, I'm sorry, remember your phase shift is H. And your vertical shift is still K. So remember, it's opposite if it's on the left side of the equation, but if it's on the right side, it's not going to be opposite. We've talked about that a lot. Now remember the phase shift here, notice that this x, the coefficient on the x is 1. So when you see some examples that we're going to look at, if the coefficient on the x is not 1, you have to factor a number out to make it 1, and then the resulting h will be your phase shift. Okay, so if we have this equation, it is the image of the graph under y equals sine of x under a horizontal scale change of 1/2, followed by a horizontal translation of pi over 8. Amplitude is 1, period is 2 pi times 1/2, which equals pi. Remember, the 1/2 comes from here. You're doing the reciprocal, because the a is really what's on the bottom of the x, which is the 1/2, not 2, the reciprocal. Phase shift is pi over 8. Again, horizontal shift is the same as phase shift, and the vertical shift is 0. There is no vertical shift here. There's no plus or minus some constant. And remember, the pi over 8, the phase shift comes from the fact, remember, like I said, this coefficient has to be 1, not 2. It has to be 1. So I'm going to pull a 2 out of this expression. When I pull a 2 out, what I have left is x minus pi over 8. If I were to multiply this in, I would get the same thing as I have here. So this expression is equivalent to this one. So now that the x has a coefficient of 1, we know that the phase shift is pi over 8. The composite of what scale change and translation maps y equals cosine of x onto y equals 3 times cosine of 4 times x plus pi minus 10. So the scale change is 1. These are the rules, remember. These are the rules, which is opposite of the equation. So the scale change here on the x value is a 4, but remember that's going to be the opposite, or the reciprocal. So if it's 4 here, it's 1/4 here for the rule. The 3 here, you're multiplying all the amplitude's 3, so you're multiplying all the y values by 3. But remember, this could be here too. So since it's y divided by 3, again, it's the opposite. In the rule, it's 3 multiplied by y. So whether you look here or here, if you're looking at the amplitude, it's not opposite. It's just 3. You're multiplying all the y values by 3. Now the translation, you're going to shift. This is a coefficient of 1. So you're going to shift to not the positive, not the right, but to the left, pi units. So you're going to shift all the x values to the left pi units and all the values down 10 units. Okay, and for number 3, you have to look at the activity in the book, and it says, how high is the person when boarding the Ferris wheel? When the person boards the Ferris wheel, no time has passed. So you can put this in your calculator. Look, the t value is the same as the x value. So what is the distance when t equals 0? That's your hint.